So we just directly go to the next discussion, next introductory speech, which is also about industrial AI. Two colleagues from TRUMPF. On the one hand, Dr. Tom Schneider. On the other hand, Carina Mieth from TRUMPF Machine Tools and from TRUMPF are talking about AI applications in the factory of the future and how this is transforming the sheet metal industry. So we directly hand over to you, and we're very interested in your thoughts and considerations regarding those issues.
Yes, thank you for the introduction, and I think we would like to give you some insights on a very specific industry segment, and as a first starting point, maybe some words about TRUMPF as one of the leading technology providers for sheet metal producing machines. So we have the laser cutting machines, punching, and including laser as a combination machine. We are developing our own bending and also the welding, and in a special case, specific machines for the tube processing to cut directly into tubes. And all of these are connected for our customers in dedicated smart factories where we would like to support them from directly from the start of the design until processing on shop floor, including logistics. And this we call TruConnect, where we bring together hardware, software, and services. And today with Carina, who's one of the experts in AI at our team, we would like to give you the beautiful overview of what is done in sheet metal. And therefore, we thought it's good to start with an overview of the end product, which we think is what we all have to drive together with applications based on AI. So it's a various and very large overview on all the industries where sheet metal is taking its role as a kind of supporting element for design. So from automotive for e-mobility in the battery box, over consumer electronics, ventilation and heating, all the things where we get our lunch from, or the industrial kitchens are very have a lot of sheet metal, but heavy metal industry in construction and mechanical engineering in itself to design parts up to consumer parts and in furniture and lamps, and whatever is driven by AI needs switches and server cabinets. So, and these are also hosted within sheet metal. So the industry is big, and the process is always the same. So we today we would like to take you into our process world and give you a presentation where the AI supports our customers by driving their product excellence. And we have three areas where we would like to talk about. It's machine and automation, it's assistance systems, and at the end, connecting everything together in software and logistics solutions. And for the first detailed insight, I would like to hand over to Carina, because everything begins with the design, and it's the first step in for AI.
Thanks. So I will start with the example of Optimate. Optimate is an AI solution that identifies design errors and cost-intensive steps. And for example, we can identify if the undercut of minimum flange length is in a sheet metal design, and this can be identified and shown to the construction engineer so that we adjust this length to a suitable length that can be produced on a bending machine. Another example is the cutouts, which can occur close to the bend zone. And this can lead to deformations on the contour. And for this, we can include some relief slots so that this can be produced reliable and without deformations. And the third thing here is to avoid cost-intensive steps like the welding process. And with an intelligent sheet metal design, we can remove this welding process with two bending steps, which is shown on the right-hand side. So this right part is optimized with Optimate and is therefore cheaper and can be produced more reliable. So that's our first AI use case. And after the construction and design, we go back to our process chain. So Tom, what's next?
So after design and gathering the data, it has to be produced. And 80% of our customers are small and medium businesses with family having 4 to 8 machines. And cutting is always the first step. So after we have designed the part and optimize it by cost and processing, we will hand it over to our cutting machines. And in the very small businesses, we have in the last years developed an AI-based tool which supports our customers in the first process step. And that will be highlighted by Carina, because it's also something where the technology of cutting the part meets AI in the next, preparing the next process step.
Yes, I will present to you the sorting guide and the challenge that we have here. So with a laser flatbed cutting machine, we cut sheet metal parts from a huge sheet. And to use this sheet very efficiently, there are a lot of orders that are nested onto this sheet. And that's a huge complexity that the worker has to tackle in his daily work. And with this sorting guide assistance system, the camera detects a part removal and locks this automatically to the system. And it also assists the worker by showing him different colored parts. And by this, the worker can easily sort the cut parts to the next process step or according to an order set. And this system was recently awarded the AI Championship from the federal state of Baden-Württemberg. And in the next slide, I will show you why we needed AI for this. And this is basically due to the fact that we have a very versatile working area there. So it's a huge space. There are a lot of different conditions that can occur. So, for example, we have different materials that can reflect the sun, or also the sun is shining through windows on the working area. We have a lot of different part geometries, or the person interacts with the working area. And all these things are difficult for a classic algorithm to cope with. And that's why we solve this challenge with an AI solution here. And I will show you this using the example of the sheet tracking, where we started with a classical computer vision algorithm and just started to implement it and collected data from our test customers and did the normal data labeling. And then we could start training a neural network to do this detection more reliable. And this was also due to the fact that it was very hard to parameterize these classic machine vision algorithms so that they work reliable in all these different conditions. And we already showed in this example that our neural network is really robust and more reliable to detect the sheet position. And this is shown also here in this little example. You see the machine area and also the sheet. So for a human, it's very obvious where the sheet is. And now this AI system can reliably detect all the parts that belong to the sheet and which are metal parts, for example, and also what is just apart from the machine. So Tom.
So and that with the handed sorted, and I think we have to speed up in the application of AI, but the next thing is speeding up the process chain at our customers and coming to more autonomous driving. And maybe we give the auditorians a short insight of how AI in autonomous producing machines is currently supporting our customers.
Of course. I will introduce the example of our fully automated Trulager Center system. And this system has an automation unit which removes the sheet metal from the residual sheet. And here you can see a not so successful try of the machine where the part gets hooked in the residual sheet. And this is due to a complex problem, namely the precise position of these shuttles and together with some pins that come from below. And this is an optimization problem, which is also shown here a little bit more schematically, because we have to define in advance where these pins should be placed in a very complex geometry. And if you put pins only on one side, you know that parts can tilt or something. And so by each part that is removed, we always save the combination of pin and shuttle placements, and the machine can detect whether the part removal was successful at first, second, third try, and so on. And if it fails at the first time, the machine is so intelligent that it can adapt the positions of the shuttles and the pins so that it tries again in another composition. And this is saved and the basis for our learning algorithms in this machine. And so we create a very robust automation unit that is the first step into fully autonomous manufacturing.
So now we talked dedicated about the manual process by assistance systems and autonomous driving. And I think it now summing it up into a process chain where we see that the logistics is after our bending and welding part, the key driver of making our customers successful. And also there we have an application support by AI, which is, I think, worth to share today.
Okay, I'll dive into that. So we just introduced, like some years ago already, the track and trace system, which is an ultra wideband based indoor localization system. And it works like, similar to the known GPS, the global positioning system, where you have satellites that are attached to the walls of the production hall. And you have mobile devices that are attached to the orders at the beginning of the production flow. And with radio signals, you can triangulate positions, and thereby we can digitize the whole material flows in a production scenario. And this is a quite interesting use case for big data analysis, because we can use each position from each order over time in the production scenario to do some very insightful analysis. And this one, which I bring to you now, is a data quality analysis where we compare the EIP data with our automatically locked position data. And in this yellow rectangle box, we have the bending area of a customer site. And we looked into the EIP data, whether an order was now clocked into the bending process or not. And to explain this a little bit, it's still a very manual process. So the worker starts his job by walking to a terminal and clocks this order. And after he finished processing, he does this again. So it relies on the worker that he always really does this at the exact time. And if we compare this with the traces that we get from the indoor localization system, we see that there is a huge derivation. And for this specific customer, we had 83% of all activities that were not in the bending area, but somewhere else. So we see that there is a huge deviation between what is locked in the EIP system manually versus what we can achieve with an indoor localization system, where each step is digitized automatically.
And now to somehow finalize our presentation of the use of industrial AI, I think it's giving ourselves in the position that we would like to optimize for our customers the full process change right before they are building up the factory, and there where all the information we have collected over the different machines and the different assistance systems come together. And this is maybe for the last 5 minutes a good outlook to see where all these came together.
Of course. So let's start this section with a little question at the beginning. So Chesco and sheet metal production, what do they have in common? And well, they have in common that they are all very complex planning tasks. So if you compare it with the size of the search trees, you see that the sheet metal processing environment is a really, really complex area where you have a lot of possibilities to optimize your system. And we compared this with the number of atoms in the universe, and you see that it's that we are magnitudes higher than this. And why is this so difficult here? Let me explain this to you a little further. So we have a really complex optimization problem, there are two problems which are closely interwoven. So on the one hand, we have a packing problem where parts are nested efficiently on a sheet metal to minimize the waste that occurs in the cutting process. And on the other hand, we have a machine assignment problem where we want to increase and maximize the utilization of the machines. And normally we have like an input stream of orders where we have different parts with due dates and values. So this is similar, or it's just a basic job scheduling problem. But then if we nest it on the sheet, we define when it's available for the next process steps. And if we then see in the production that a machine has a low utilization, we have to go back and adapt the cutting. And then you can see that it's just a vicious circle. And if you optimize only on the one side, you get a bad result on the other hand. And what we did there last year with a student of mine, Alexandru Înțiuc, we used the AlphaGo Zero algorithm to optimize our sheet metal production scheduling. And this showed some good results. So please check this out if you want to know more about that. And also Alexandru is doing a PhD in this topic now. So that's a quite interesting thing here. And with reinforcement learning, you know that you always have to have a precise model of reality, which you can use to evaluate your goal function. And this model is a digital twin for us. So digital twins and AI are a very perfect combination. And I want to show you why. So our simulation that we use in our digital twins is an agent-based and discrete event simulation. And this modeling paradigm is very nice to do AI stuff with it, because this agent paradigm is very similar to learning and training agents with a reinforcement learning policy. So that's what I showed you before already. And there are other important pros. So if you want to do data farming, for example, to abstract a complex simulation model, you can use this model and generate in and output behavior and train models to abstract this behavior with a better response time. And also you can play out the model to generate traces for rare cases. And the last thing is that you can also use these models and digital twins as test beds for your trained networks. And as you know, simulations are a risk-free environment. So if your AI does something weird, it only crashes the simulation and not the real production scenario. So that's it. Tom, please conclude why we have a sweet spot here with our industrial AI.
So it's like we tried to convince you that it's a very nice setup to use AI in a real industrial environment, and we took over as a final remark that we take the statement from Alan Kay, and people who are really serious about software should make their own hardware, and I think we would like to transfer it a little bit, and people who are really serious about industry should make their own machines. And that's how we would like to hand over to the audience again. And thanks for having the opportunity to present here. And everybody who's interested in follow up with Carina or myself on how we try to transform a specific industry with the help of AI, but also with a lot of machinery and still the domain expertise coming out of all the engineering schools around Europe and the world to have really the good starting point for AI, because it's the data coming out of the machines and being used to support our customers for better products. And that's a simple circle we would like to present. Thank you very much.
Thanks a lot. So there are a lot of questions in the chat, which shows to me that this was a very interesting presentation. So feel free, as the colleague said, to connect to the both of them. I think we have just time for one question. So there was one question regarding ecosystem. You just mentioned it in your final considerations, but can you give us some more deep insights into how you communicate results, communicate new operations you use at TRUMPF to your ecosystem partners?
Yeah, so thanks for this interesting question. So the first thing is we are driving the initiatives like UMATI for an open standard and open communication standard for all machines together with the colleagues of machine tool industry. And we are also driving OMLOGS as an open standard for ultra-wideband communication and gathering data across industry and companies because we think in openness. And finally, the pre-call talk from Siemens was about the European way of implementing Gaia-X and driving this in Industry 4.0 Alliance or the Catena-X activities. And we are part of all these activities. We try to transfer our whole industry in the kind of an open factory core where we share the data to allow for our customers to do their own use cases and improve their production chain. And that's where we clearly think the future is. So we would like to have this openness and drive all we can do within the ecosystems that the future of manufacturing is driven by AI and data with good machines from Europe. So we try to do everything there. But it will be a long way.
I think that's a perfect final statement. Thanks a lot to both of you for this very interesting chat. And as I said, feel free to connect to the two colleagues from TRUMPF to interact and to discuss in depth during the Big-Data.AI Summit today and even afterwards. Thanks a lot. See you.
Thank you very much and have a good day. Bye-bye.